Waalaikumsalam. Good morning,
Waalaikumsalam,
Doktor.
Doktor.
Boleh mula?
Boleh, Doktor.
Okey. Jadi saya share screen, nampak ke slide saya?
Nampak, Doktor?
Okey. Okay, so jom start. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning. Today we are going to learn a new chapter, which is the discrete distribution. Okay, so this is the probability as well. So probability for the discrete distribution. Okay. So after we complete study this chapter, you are able to compute the probabilities from the discrete distribution, and you are able to use the discrete probability plot to determine its application in finance and compute probabilities from the binomial, Poisson, and hypergeometric distribution. Okay, so firstly, we want to know what is the probability distribution. Okay, so probability distribution is a list of all outcome of an experiment. Okay, and the probability will be associated with each outcome. Sama macam kita nak buat cari probability for tossing coin, rolling a dice, and so on lah. Okay, and the characteristic of probability distribution, okay, the probability of a particular outcome will be between 0 and 1 inclusively. So probability of the outcome, okay, let's say event outcome is X, is between 0 to 1 inclusive. Okay, and the outcome must be mutually exclusive. Okay, mutually exclusive, we already learned this in previous chapter, chapter 3. So mutually exclusive is what? The outcome or the event only one event is occur at the same at the time. Okay, and the list of outcome is exhaustive. Okay, so the sum of the probabilities of the all outcome must be equal to 1. Okay, for example, exhaustive mean at least saya tu tukar mutually exclusive dengan exhaustive. What is mutually exclusive? Google jap. And collectively exhaustive. Minggu lepas kita dah belajar ni. In a simple word, what can we say about mutually exclusive and collectively exhaustive? Dua ni selalu ada dalam probability. Siapa nak bagi tahu sebelum saya panggil nama?
Doktor,
Ya.
yang mutually eksklusif tu dua event yang tak boleh berlaku serentak.
Betul. Okay, so 2 event. Only one event occur at one time kan? Okay, and collectively exhaustive? Siapa nak bagi tahu? 2 event cannot occur at the same time. Cannot occur at the same time, while for collectively exhaustive, at least one event must occur. Betul?
Betul.
Okay, and then kalau kita tambah semua event, okay, semua probability of the event, it must equal to 1. Contoh macam probability of getting head is 1/2 and probability of getting tail is 1/2. So kalau kita tambah these two probability, it will become 1. Okay. And this tossing coin is called as a mutually exclusive because head and tail cannot occur at the same time and at least one tail or one head must occur. So it is mutually exclusive and collectively exhaustive. Boleh?
Boleh.
Okay. That's the characteristic for a probability distribution. Okay. So let's look at the example. Suppose we are interested in the number of heads showing face up with 3 toss of a coin. Okay, maksudnya kita nak toss a coin 3 kali and then kita nak the successful event is when we getting head. Okay, this is the experiment. So the possible results are we are getting 0 head, 1 head, 2 heads and 3 heads. Okay, so toss sekali, toss 3 kali tu tak ada pun dapat head. Maksudnya 3 tu adalah tail. And then toss lagi dapat 1 head ataupun probability kita dapat 2 head ataupun 3 head. And then what is the probability distribution for the number of heads? Okay. Okay, this is the experiment lah. Okay, so possible result. Let's say we toss a coin 3 times, we are getting the first trial tail, the second trial tail, and the third trial also tail. Okay, and then the number of heads in these 3 trial is 0. Okay, and the next experiment, okay, the first trial is tail, the second is tail, and the third one is head. Okay, and then the number of head is 1. Okay, and followed by the third until the 8th experiment lah. Okay, and then you can see that we are getting 1, 2, 3, 1 head. Okay, 0 head is 1, 2 heads is 3, and 3 head is 1. Okay, so these are the possible results that we will get if we toss a coin 3 times. Okay, so we want to find the probability. So the probability distribution, how are we going to find the probability distribution? Okay. We can write number of heads, okay, which is denoted as X. Okay, is we will get the possible outcome 0, 1, 2, and 3. Kan? And the probability of getting hit. So probability of getting hit of the outcome, which is P of X. Okay. So for 0 hits, for not getting any hit, we have 1. 1, 0. So the probability is 1 over the possible result, which is n equal 8. Okay, so you will get this equal 0.125. Okay, and then the probability of getting hit, of getting 1 hit. So we have 1, 2, and 3. So the probability is 3 over 8 equal 0.375. Okay, how about 2? So number of hits, we are getting 2 numbers of hit, 1, 2, 3. 3 juga. So 3 over 8 equal 0.375. And for getting 3 hits is 1 over 8 equal 0.125. And we can see that the total outcome of these 4 outcomes is equals to 1. Boleh? Any question? So the possible result here ni, you can list down lah, kan? If we want to toss a coin three times, then these are the possible result. There are 8 possible results. And if let's say the question asking for number of heads showing face up with 2 tosses of coin. So you kena list down the possible result. Ada berapa possible result? It must be less than 8 lah, because we just toss the coin 2 times. Okay? Boleh? Any question? Boleh ke?
Boleh.
Okay, kalau boleh saya proceed Okay, so before we go further, let's look at the random variable dulu. So the random variable is a quantity result from the experiment. Okay, for example, let's say I want to know the number of students join the class today. Okay, so that will be the random variable lah. Okay, so for today, there are 36 students, okay, joining the statistic class today. And for last week, let's say there is 33 students, okay, was joined the class last week, and so on lah. So the number of students, okay, join the statistic class is the random variable. Okay. And let's say the grade level. Okay, so the grade level, there are freshmen, sophomore, junior or senior of the members of St. James High School basketball team. So the grade level is random variable as well. Okay, since this grade level is in category, so this grade level considered as a qualitative variable, meaning that we cannot. This is not the quantity, but how about the number of students or the number of employee absent? This is this random variable considered as qualitative or quantitative variable. Panggil nama lah. Sophie ada? Sophie?
Yes, ada.
Sophie. Number of students join the class today or the number of employees absent considered as a random qualitative random variable ataupun quantitative random variable. Number of students or number of employee. Qualitative or quantitative?
Kualitatif.
Kuali?
Kuanti.
Kenapa kuanti?
Because the number.
Betul. Boleh kira lah. Kan? Number. Nasib baik betul. Boleh ke? Yang lain?
Boleh.
Okay. So as I mentioned just now, quantitative and qualitative kan? Okay, so there are two types of random variable juga. So which are discrete random variable and continuous random variable. Okay, apa beza discrete and continuous random variable ni? Okay, so the discrete random variable, the random variable that we can kira lah. Okay, so kita boleh tulis dia punya value. Okay, contoh 0, 1, 2 dan seterusnya. Okay. Contoh macam tossing a coin 3 times and getting the number of hits. And also let's say RHB bank counts the number of credit card carried by a group of customer. So maksudnya dalam RHB credit card contohnya dekat nilai, so dia boleh tahu how many customer yang ada credit card. Okay, and for the continuous random variable, okay, so the random variable will be in a interval. Contoh macam temperature, contoh macam hour, duration of hour, the annual rainfall, okay, and so on lah. Okay, so kalau kat sini, there will be the decimal lah point kan. Okay, so contoh macam the time between flights from KLA, daripada KLA to KK and KK to KLA between 4.67 hours, ada yang 5.13 hours and so on lah. Boleh? Boleh Doktor. Okay. Okay. So in discrete probability distribution pun ada mean and variance. So mean also referred as expected value. Sometimes in discrete probability distribution, question not asking for mean, it is asking for expected value. And then you can note lah yang the expected value is actually mean. Okay. So the mean of a probability distribution given by this formula. Mean equal total of x time probability of x. And the variance of the probability distribution is given here. Total of x minus mean squared times probability of x. Okay, and the standard deviation is the square root of the variance. Okay, so let's look at this example. John sells new car for Pelican Ford. Okay, John usually sells the largest number of cars on Saturday. So he was developed the following probability distribution for the number of cars he expects to sell on a particular Saturday. What type of distribution is this? So this is called as a apa?
Discrete.
Discrete probability distribution. Why? Because the value is separated. Okay, we have 0, 1, 2, 3, and 4. Meaning that the random variable, this is the random variable. Okay, it can be written in a integer lah, 0, 1, 2, 3, and 4. So these are the expected number of cars sold by John on Saturday. Okay. Apa tadi? Discrete probability distribution. Okay. And how many cars John expect to sell on a typical Saturday? So the main keyword here is expect, meaning that this is the expected value. So we are going to find the mean. Okay, so to find the mean, dia punya notation adalah mu kan? Okay. Mu equal sum of x times probability of x. Okay, so x is referred as 0, 1, 2, 3, and 4. And the probability of x is given here. So dah ada dah table kat sini. Okay, so you boleh darab lah kan. Okay. So saya tambah lagi satu. X times P of x. 0 times 0.1. 0 times 0.1. Okay, this is 1 times 0.2. 2 times 0.3. 3 times 0.3. And 4 times 0.1. Boleh tak you dapatkan total of x darab P of x?
Tu
2.1.
Betul, 2.1. So he expected, meaning that the mean of John sell the car on Saturday is 2.1 car. Okay. Since 2.1 tak mungkin lah kan. Takkanlah 2 lepas tu tambah dengan 0.1 untuk car yang lain. So it's expected. Kalau in a whole number, then you boleh katalah John expect to sell 2 cars on the particular Saturday. Boleh? So this is mean. Boleh ke tak boleh?
Boleh.
Okay, boleh Okay. So ini yang tadi, number 2. And then the number 3, we are going to find the variance. Okay, variance, we will use this formula. X minus mu, which is mean, squared times with probability of x. Okay. So x is given from 0 to 4. This is the probability. Okay, and x minus mu, meaning 0 minus mu is 2.1. Okay, so we're getting these values, and then x minus mean squared, we are getting this value. Then x minus mu squared times the probability. So this value times with the probability of the correspond x. So we are getting this value. And the total of these 5 value equal 1.29, which is the variance sigma square. So this is variance. Boleh ke ada soalan?
Boleh.
Boleh. Okay. So dah habis dah untuk discrete probability. Boleh ke kalau let's say nanti this one will be covered in final exam lah. Okay, so next the binomial distribution. Okay, so for the binomial probability distribution, there are 4 requirements for the distribution to be binomial. Okay, so apa requirement dia? So the first requirement, there are only 2 possible outcomes. Okay, 2 possible outcomes, and the outcomes are mutually exclusive. Okay, maksudnya the outcome cannot occur both at the same time kan, and as either the outcome must be either success or failure. Okay, outcomes are mutually exclusive, either success or failure. Okay, the number of trial is fixed and known. Kita tahu the number of trial. And the probability of success is the same for each trial. Okay, and each trial is independent. Okay, since the probability of success is the same of each trial, meaning that the trial is independent lah. Contoh, macam a young family has 2 children, both boys. Okay, so this is the binomial probability distribution because there are only 2 possible outcomes, either boy or a girl. Kan? Okay, so first child, either boy or girl. Since and it must be mutually exclusive. Betul lah, boy and girl cannot occur at the same time. Either only one can be occur. Okay. And since this young family wants to get boy, so meaning that getting a boy is a success experiment lah. Okay, if let's say it's getting girl, then it is failure. Boleh? Boleh tak untuk the first requirement? Faham ke?
Kat ni boleh doktor.
Okay, and then the second one, the number of trial is fixed and known. So kita tahulah dia nak 2 trial. Okay, because we are getting the young family ada 2 children. Okay, and the probability of success is the same for each trial. Betul juga sebab getting boy kan. Okay, so getting boy, the probability is 1/2. And untuk the first child, and the probability of getting boy on the second child also 1/2. And even number 2, okay, is not dependent on the first child. Betul tak? Kalau yang first ni boy, yang second ni apa ni? Tak ada pun condition yang kata kalau first boy, the second boy. Tak ada. Okay, this is the second child is independent. Okay, dia tak bergantung kepada the occurrence of the first child. Okay, so this is the example of this binomial probability distribution. Boleh ke?
Boleh.
Okay. So untuk binomial probability distribution, N is referring to the number of trial and the probability of success is denoted as pi. Okay, pi ni ada value, bukan value yang 3.1416 ni tau. Okay, so pi ni is the probability of success. It depend on the question later lah. So what is the probability of success? And the formula for computing the binomial probability is given in this formula. N Cx pi, which is the probability of success to the power of random variable x, 1 minus x, pi to the power of n minus x. Okay, jom try satu example. Okay, so recently the creditcard.com reported 28% of the purchases at the coffee shops were made with a debit card. Maksudnya 28 purchase from the debit card. Okay, paid by debit card. For 10 randomly selected purchases at Mesa Mall Starbucks, what is the probability exactly one of the purchases was made with the debit card? Okay. So probability of getting X equal 1. So kita nak cari probability of one purchases was made by debit card. Okay, so purchases, percentage of the purchases by using the debit card is 28%. So this is the considered as the probability of success. Okay, probability of success is probability of purchases using debit card. Berapa? 28%. So 28% equal 0.28 lah. Okay, and satu lagi ada apa? Ada N kan? Number of trial. Berapa number of trial? Berapa number of trial?
10.
10, betul. Baru nak panggil nama. Terima kasih. Okay, so X depend on the question lah. Okay, since A, we want to find the probability exactly one of the purchases made by debit card. So kita nak cari P of X equal 1 ataupun P of 1 lah. Okay, from the formula N C X, C is the combination darab pi kuasa X darab 1 tolak pi kuasa N tolak X. Okay, so N 10, C X, C 1. Okay, darab pi 0.28. Kuasa 1 darab 1 tolak 0.28 kuasa 10 tolak 1. Boleh tak tolong saya cari jawapan? Berapa tu? Tahu tak nak guna calculator tu? Untuk C, 10 shift bahagi. Atas bahagi tu you boleh nampak NCR. So bila you tekan shift bahagi tu, screen akan display C. Jumpa ke?
Jumpa doktor.
Okay. Dapat berapa?
0. Okay.
Okay. Sila. Tak apa, you dulu. Nanti kita panggil orang lain lagi.
0.21.
0.21. Alamak, salah tu.
0.15.
0.145, betul. 1455, lah. 1.46. Ataupun 0.1.5. Boleh tak? Siapa yang tadi 0.2 tu? Kat mana salah? 10 C dapat? Display tak C dekat screen?
Display?
1
Ada.
darab 0.8. 0.28. Darab 1 tolak 0.28 kuasa 9.
Okey doktor, saya silap 1 tolak 0.28 tu saya letak 1 tolak 0.25.
Okey. Okay, ini jawapan yang betul. Terima kasih. Okay, yang bawah tu. What is the probability distribution for the random variable number of purchases made with a debit card? Maksudnya nak cari untuk semua lah. Okay, bila X equals 0, X equal 1, 2 until X equal 10. Boleh tak you cari? So 1 dah ada. Carilah untuk 0, 2, 3 seterusnya sampai 10. Boleh tak? Ada tak? Kat sini sebenarnya. Okay, so nak cari ni sama je. You ganti X0, X2, X3 seterusnya sampai 10 and then at last you akan dapat this probability. Nanti you try tau. Boleh? Boleh ke tak boleh? Okay. So yang ni untuk B nanti you try. And then untuk C, what is the probability that 6 or more purchases, kenapa tu? 6 or more purchases out of 10 are made with a debit card. So kita nak find the probability of apa? 6 or more. Maksudnya X.
Maksudnya pada start ada 6 lah. 6 ke 10.
6 per 10. X lebih besar dan sama dengan 6. So jadi kita nak P when X equals 6 plus P when X equals 7, 8, 9 and 10 lah. Okay, 8 tambah probability X equals to 9 plus probability X equals to 10. Boleh ke cari? Boleh? Cuba cari jap. 2 minit. 6, 7, 8, 9, 10. Ganti dalam formula ni. Apa tadi? Oh. Ain Zulaika. Ada?
Ada doktor.
Probability when X equals to 6 sama dengan?
Sekejap doktor. (0.027).
0.027. Imran, probability when X equals 7.
Kejap doktor.
Okay. Imran 7, 8, Fatin. Fatin ada 2 ni. Fatin Farzana. Fatin Farzana 8, 9 Akil Azib, 10 Akilah. Nur Akilah. Alamak, Fatin Nur Akilah juga. Nur Akilah je. Tak ada Fatin. Imran dah? Bila X sama dengan 7.
Kejap sikit lagi, sikit lagi.
Sikit lagi? Okey.
Yang 7 tu 0.006.
0.006, betul. Next, siapa tadi? Fazana. 8.
0.001.
001. Siapa? Akil Azib. Bila X sama dengan 9. Akil tak ada?
Oh, ada.
Oh, ada. Alhamdulillah. Okey, apa Akil? Jawapan dia?
Saya dapat 0.00076
Okey, kita ambil 0 je lah. Sebab kita ambil 3 desimal kan. Okey, dah 7 tu dah ke 4 dah kan? Kosong lah. Okay, and then last Nur Akilah.
Saya dapat 0 juga doktor.
0 juga. Okay, so total Akilah. Berapa? 0.0?
0.034.
0.034. Sama ke jawapan kita?
Sama.
Sama? Okay. So tu untuk C lah. And then untuk D, what is the probability 5 or less purchases out of 10 are made with debit card? So nak cari apa? Nak cari probability 5 or less. So X less than or equals to 5. Okay. Since this is complement probability kan, sebab last kali dia akan dapat this probability ni, you akan kira you akan dapat 1 tau. Okay, so kita boleh guna D, either you boleh cari probability X equals to 0 tambah probability X equals to 1 until probability when X equals to 5. Or kita tahu yang less than or equals to 5 ni adalah 1 tolak probability when X greater than or equals to 6 yang kita dah dapat dah dekat sini. Okay. So by using answer in C, so 1 minus 0.034, so you dapat berapa? Probability when X less than or equals to 5. Nak panggil nama ke? Aina. Aina Najwa. Ada?
Tidak tu.
Berapa Aina jawapan? .966. Betul? Sama?
Sama.
Sama Okay, boleh? So nanti you boleh completekan B tau. Cari probability untuk setiap X from 0 to 10. Make sure you dapat sama dengan this. Nanti saya rasa tak ada kot dekat you punya notes. Nanti you ni lah screenshot. So sikit. Okay. Okay, boleh? Ada soalan? So far so good?
Boleh.
Boleh. Okay. So jom next. Hari ni saya habiskan binomial je tau. Sebab tutorial banyak and then tutorial tu untuk cover dalam midterm kan. Okay. So yang lain nanti saya buat videos. Okay. So shortcut formula for mean and variance. Okay. So mean untuk binomial distribution can be found by using this formula juga. Mu, which is mean, equal n times probability of success. Okay, so pi ni adalah probability of success. If let's say you are getting macam tadi kan. Macam tadi kan kita ada n equal 10 and probability of success equal 0.28. Then nak cari mean, bolehlah you cari darab. So dapatlah 2.8. Okay, and to find the variance, if we have n and probability of success, the variance can be found by using this formula. Yeah. Okay, dapatlah variance for the previous example just now, 2.016. Kalau you perasan siapa-siapa yang ada buku, belakang tu ada binomial probability table. Dengan saya tak ada buku tahu sekarang. Saya tak bawa bukunya. Nanti you boleh tengok dekat belakang tu ada binomial probability table. Okay. Okay. So one example we can find by using the table. Okay, let's say in Southville 5% of the cell phone calls are dropped. Okay, terputus. What is the probability that out of 6 random Sorry yang ni sepatutnya ayatnya dekat atas ni. Out of 6 randomly selected call, okay, meaning n equals 6 and pi, which is probability of success, okay, 5% or 0.05. None was dropped, means x equal 0. Okay, when x equals 0, from the probability table, you kena cari probability tu dia ada n0, n1, n2, n3 dan ada juga n equal 6. Okay, you kena guna table yang ni, n equal 6. Okay, jumpa tak? Cuba tengok. Ada tak buku dengan you sekarang? Saya tak ingatlah page berapa. Siapa yang buka tolong sekejap bagi tahu berapa, page berapa?
Satu lapan enam.
Okay, page 186. Okay, jumpa tak? Binomial probability table and cari n sama dengan 6. Jumpa? Okay, and you akan nampak bila n sama dengan 6, yang x ni dia akan start from 0 sampai 6 sahaja. Betul?
Betul.
And then, you nampak dekat sini kan? Row, column x per ni bukan per tapi atau lah. So x ni refer kepada column 0, 1, 2, 3 sampai 6 ni. While for pi pula, this is the probability of success lah. 0.05, 0.1, 0.2, seterusnya sampai 0.95. Okay, since our example, the pi is 0.05, then kita akan tengok this column sahaja. Bila pi equal 0.05. And, okay, so when x equals 0, the probability is 0.735. So you boleh, so kat sini, probability when x equals 0 is 0.735. Okay, tak confident lah, betul tak? Betul ke jawapan ni? You boleh gunalah binomial formula tadi kan? N, which is 6, C0 times 0.05 to the power of 0 times 1 minus 0.05 to the power of 6 minus 0. Cuba cari guna kalkulator, dapat tak 0.735. Cuba jap. Dapat ke? Okay. Kalaulah you dapat soalan kan. Soalan tu you boleh guna table dan you boleh you guna je lah table. Let's say ada yang tak ada. Macam tadi tak ada kan. Macam tadi tak ada, kita kenalah guna formula. If let's say boleh guna table, then you guna table lah. Okay. So B exactly 1. So P when x equal to 1 sama dengan Fatin Nur Akilah. Ada? Berapa Fatin Nur Akilah?
0.272.
Betul. So bila x sama dengan 1, probability sama dengan 0.232. 0.232. Okay. And C probability when x equals to 2 equal inilah 0.031. Betul ke Imran?
Set. Dia panggil nama. Set.
Betul doktor.
Okey. Terima kasih. Imran, sebut satu nama girl.
Nama apa?
Nama apa? Cepatlah, tak ingat dah lama tak jumpa kan? Cepat Imran.
Aduh.
Cepat. Nak suruh dia jawab ni. Probability bila X equal 3. Senang je.
Perempuan takkan sangat, kena lelaki je.
Lelaki boleh lah. Siapa?
Boleh.
Boleh.
Amirul Hakimi.
Amirul Hakimi. Oh ya, ada Amirul Hakimi. Tadi senyap je.
Ada doktor.
Ada berapa Amirul?
Sekejap doktor.
Nak guna formula ke, nak guna table ke boleh. Cepat jawapan dia.
Jawapan dia 0.02.
Betul. 0.02 kan yang ni.
0.002.
Okey, jauh sikit yang kawan tu. Okey, 4, 5 dan 6 jawapannya adalah bila X sama dengan 0, X sama dengan 4, X sama dengan 5, X sama dengan 6. Jawapan dia 0, 0, 0. Boleh ke?
Cik, dia sebut nama tu.
Ada soalan? Boleh? Okay, last satu lagi example. Sekarang pukul 9.13 dah. Okay. A study by Proton conclude that 76.2% of front seat occupants wore seat belts. Okay, that is both occupants of the front seat were using seat belt lah. Okay, suppose we decide to compare the information with current usage. We select a sample of 12 vehicle, mean N equals 12 lah. And what is the probability that the front seat occupants is exactly 7 out of 12 vehicle are wearing seat belt? Since kita nak cari probability the occupants, the front seat occupant wearing seat belt, so meaning that the probability of success is yang ni lah. Okay, sebab the 76.2% is the percentage of the front seat occupant wearing seat belt. So this is pi. Pi sama dengan 76.2% is 0.0762. Okay, the probability. Okay, and we want to find probability exactly 7. Exactly 7 means X equal 7. So kita nak cari P when X equal 7. Boleh cari? Saya nak 1 dan 2. Cuba try Buat dulu. Saya panggil nama. Siapa? Amirul dah, Imran dah. Tak nak. Lelaki bagi yang susah. Yang perempuan senang-senang je. Aisyatul Humairah A. Boleh? Saya dah jumpa dah. Amir B. Amir ada? Ada Amir? Boleh Amir? Boleh. Semangat sikit Amir. Aisyatul Humairah tadi ada ke?
Ada doktor.
Humairah semangat. Okay, cepat-cepat cari jawapan sebelum kita pergi kepada tutorial.
Oh.